Redox equations can be written as half equations. Each half represent either oxidation or reduction. Then you might have easier time to balance them. The first case is really easy. Let's just go after like species. So bromine versus bromide. So I write that half equation. First thing I'm going to do is make sure my atoms are balanced. So I put 2 bromide. And then I have 2 negative charge on the product, so I'm going to gain 2 electrons on the reactant side, and this is half reduction equation. Then let's go after the other species, iodide versus iodine. So I have I minus, that is becoming I2. Balance the atoms, so 2 of this. You have 2 negative charge, let's balance the charges, so we are going to lose 2 electrons on the product, and it's half oxidation. The last thing to do is sum them up, and electrons have to cancel each other out. Those that are gained and lost should be exactly equal. So final answer, the balanced version is just having a coefficient of 2 for the halides. Now this was easy. Let's look at complicated ones, which are not really complicated, but they are known as acidic solution or acidic redox. Every time you see oxygen on one side and it's not on the other side, you should realize this is acidic and you need hydrogen ions and H2O. So let's go after like terms. I go after iron 2 versus iron 3. So let's just put it and see if it's oxidation or reduction. Number of ions are the same. All I have to do is make sure 3 plus is equal to 2 plus by losing 1 electron. So this is half you losing, so it's oil, half oxidation. And this was the easy part. Now let's go after the one that has chromium in it. So we put Cr2O7 2 minus is versus chromium 3 plus. The first is number of atoms. You see 2 chromium here, so I'm going to put coefficient of 2. The second thing I need to do is make sure oxygens are balanced. The side that you're missing oxygen, you need to add H2O. Every 1 molecule of H2O provides 1 atom of oxygen. You need 7 oxygen, so put coefficient of 7. But once you do that, you have introduced hydrogens. So the side that you're missing hydrogen, put H, but realize those are H pluses. It's hydrochloric acid, sulfuric acid, it's acidic environment. 7 times 2 is 14, so I have 14 hydrogen. The last part, which majority of us have difficulty, is you have to make sure charges are balanced. So multiply coefficient by the charge. 14 times plus is 14 plus, and you have a 2 minus here. So I have 14 positive charges plus 2 minuses, and that's total of 12 positive charges on the reactant side. On the product side, I only have chromium, so I have 2 times 3 plus, which is 6 plus. Now, how can I make 6 plus equal to, 12 plus equal to 6 plus? By gaining 6 electrons on the reactant side. And it makes sense. I had oxidation, I was looking for reduction, so this is half reduction. The last thing to do before we can sum them up, you have to make sure number of electrons are equal on both sides. Here I have 6, but on top I only have 1 electron, so I'm going to multiply the entire thing by a factor of 6. So we are ready. 6 times Fe is 6Fe2 plus, if you do that, the 6 electrons cancel each other out. The remainder of the reactants, you have 14 H pluses, which represent your acid, plus dichromate ion. On the product side, don't forget the 6 gets multiplied by all of them. So you have 6 iron 3 plus 2 chromium 3 plus 7 H2O. This reaction is balanced, and you can look at number of atoms. They are all the same on both sides.